Welcome to this tech tip on utilizing Autodesk Inventor to work with groove cut, foam board, or cardboard. My name is Rusty Belcher and I'll be going through this customer request tech tip with you today. I was on site with a customer last week and they pulled up an example. Let me see if I can find that image for you real quick. They pulled up this example of a chair. This chair is built out of cardboard. I like the phrase engineered cardboard. This cardboard is very, very thick. It's about 3/8 of an inch thick. And to get the sharp corners, they actually cut a groove on one side of the board so they can fold and glue it to the desired shape. As you can see here in this corner, they also roll the corner as well. And basically they make multiple cuts so that they can do a fabricated roll effect to the cardboard. And they had a simple question: how can we build products like this with Autodesk Inventor? Now, I'm not sure that I'm actually calling this process with the correct term. For the most part, I have found groove cut cardboard or groove cut particle board, groove cut foam board on the internet, and there's quite a number of images that basically show what we want to produce with Inventor. Here you can see a simple box where they pre-cut the miters on one side of the box so they can easily fold up and generate the box. You'll see a number of these options available. Again, just going through Google Images and what people are doing with these pre-cut grooves on one side of either foam board, cardboard, or particle board. So here is my take on that simple little cardboard chair made from the engineered or pre-grooved cardboard. As you can see, I was able to produce this with Autodesk Inventor, and if I zoom in, you can actually see the mitered corners in the part or in the thick cardboard area. You see the multiple cuts that allow us to roll the part up. And basically, I was able to use Inventor's sheet metal tools along with the unfold and the refold command. There's a specific workflow that I want to share with you as to how I generated these components. Now again, just to be more clear as to what I'm talking about, I've got the seat portion of this design pulled up by itself, so we can see, I think, in a little bit clearer example what we're trying to achieve with Inventor's sheet metal tools. If I were to go into the flat pattern of this component, you actually see the grooves that are cut into the part before it's rolled up or bent up into its final form. In many cases, they're simple mitered cuts for a 90-degree bend. They want this very thick cardboard to have a very sharp outside corner. In order to do that, we need to remove material so that we can fold it up to the outside corner. In cases where you want to roll it, they basically make multiple cuts through the part so that it can be rolled up very nicely. And in this case, this is actually not a 90-degree bend, so you need to adjust the miter accordingly for bends that are not 90 degrees. We'll go back to the folded model and let you see it one more time before we get started with the demonstration on how to produce this particular part. So I've got my Inventor application open and I want to begin a new component. I'm going to select File, New, and I'm going to go to the sheet metal template. Before I get started, I want to set my settings for the sheet metal operations. I'm going to do that with the sheet metal defaults here. Now this should be done formally in a template, but just to keep things simple, I'm going to uncheck Use the Thickness rule, and I'm going to type in the thickness of the outer skin of the material. Now I'm comparing the outer skin on this cardboard to something like my business card. I measured that, and 0.01 was the thickness of my business card, a thick card stock there. So that's the thickness I'm going to use for the outer skin of the cardboard. The cardboard overall is about 3/8 of an inch thick, but as far as the bending operations go, this is what I want Inventor to think about when it's generating the flat pattern in regards of thickness. That's all I have to change here, and I'm basically ready to get going. I'm going to start off with a sketch on my top plane, And let's see, I'm going to draw a rectangle from the center out. You can draw a rectangle or any shape you want here. Simply going to make this 10 by 10. We'll finish the sketch and we'll face that. Now I'm just going to face mine downwards. That's just a personal preference. It would not matter for the overall part. All right, on this side I want to add a flange. So I'm going to add a flange to the lower side. And remember the roll that you saw there. To get the roll, I'm going to modify the default bend radius to 1 inch. And the overall length of this is going to be 3 inches. So you can see the roll and the flange there. I'll click OK. Again, we're just modifying, or I'm sorry, we're modeling the outer skin of the component at this point. I'm going to add another flange on the inside here. And I want to put that back to the default bend radius. And this is only going to be 2 inches in this particular example. And finally, the last flange on the other side here, this one's not 90 degrees, it's actually 100 degrees. All right, so we want to keep that in mind a little bit later. 2 inches long is just fine for this, and I'll click OK. So that would represent the outside skin of the part. Now, it's really important as far as this video and this tutorial goes, that I only have a process where all of the cuts, all of the pre-grooved miters and roll marks are on one side of the part. So I have to model a clean side, which in this case is the outside of the material, and all the cuts would go on the opposite side. If you had a situation where you're basically bending a Z, where you're basically would have to cut grooves on both sides of the part, I really don't have a solution right now for that, but in most cases I think all of the grooves would be on one side of the material. So that's what we're going to work through here. Now, the next step would be to temporarily flatten this out so that I can add the grooves on one side of the component. Now, to do that, I'm going to use the unfold command. Up here on the sheet metal panel, I'm going to click unfold. You simply select a stationary reference, which in this case is this face, and I'm going to choose to unfold all bends. I'll click OK, and you can see that I have a faced version of the flat pattern. And when I say a faced version, I mean that I have individual faces for each segment of the sheet metal part. Now we're going to work on the bottom side of this, and we're going to add the thickness of material first, and then we'll add the profiles of the grooves. So I'm going to start by sketching on a face, and it's very important in this workflow that I preserve some piece or some small sliver of the original face in order for the sheet metal tool to unfold it properly downstream. So to do that, I'm simply going to offset just a little bit off to the inside here. Now, because I'm going to have to do this multiple times, I'm just going to call this a parameter. I'm going to name the parameter just the letter O. We're going to set that equal to 0.01. I have found that as long as the thickness of the material is equal to or greater than this offset, everything works fine. If you try to make this too small, the part won't refold correctly. So we're just going to use the 0.01 here. You could play around with the sizes on your example, on your processes. You might find obviously different dimensions would work better or could cause issues. So I'm just showing you just the default dimensions I'm using here. So I have a very little, small little sliver here. What I can do while I'm basically on this sketch, I can go ahead and project the other faces. We'll go ahead and offset each of these in turn. Just now O, enter for that offset value. I'll project this face, and this face, and then I'll just do the offsets one more time, making sure to come in that 0.01. So there we go. So we've left a little bit of a remnant of that external skin. And now we can thicken our part. I'm just going to use the extrude command for that. I'm just going to select each of these profiles in turn. And the overall thickness, 0.375. There we go. And we'll click OK. Now for the 90-degree bend here, it's fairly straightforward. All I have to do is add a simple chamfer to each of these edges. And this will be the preset groove for that 90-degree bend there. Put the check mark there. Down here, remember that we need to fold it tighter together because it's a 100-degree bend instead of a 90-degree bend. So in this particular case, I can't use the default chamfer. What I need to do is a distance and angle chamfer. So from this face right there, that edge, I believe we're going to go 40 degrees. We'll apply that and do the same thing on the other side there. I'll click OK. So we've got that set up correctly. Now for the roll. Now again, this is my take on the roll. Your geometry might be a little bit different depending on your manufacturing processes. But I'm going to sketch on the side of the face here. And I'm just going to start with a reference line. We'll come down right there. I'm just going to make it a reference line. And I'm going to draw a V-cut. So I'm going to go from there to there. And we'll go from here to here. The dimensions on this, about 2.5 degrees. Again, your dimensions will probably be different than mine, but about 5 degrees overall. And I'm going to dimension it from this point here to this corner. We'll just wait and make sure I mark the corner. 0.25. We'll enter there. Now I'm just going to do a simple extrusion. I'm going to cut this through everything, so cut through all. There's our V cut there. I want to pattern that. So I'm going to go to my pattern tool, select that V cut. The direction, I'm going to go with this edge here. I want a total of 5 cuts here. I'm going to have to measure, so bear with me here. I'm going to measure from this point all the way down to this point. And I'm going to divide that by 6. So basically I have an equal spacing for those 5 little V-cuts there. So we'll click OK, and we've got basically the cuts in the part that'll allow us to roll up the component. So now that I've got my grooves cut, it's time to refold this to get our desired piece. So if I flip this back over, we'll go back to the sheet metal tools and we'll select refold. Now again, we simply select the stationary reference. In this case, I'm going to select all bends again, and we'll click OK. And here you have the rolled up piece of material. Now, as you can see here, I think I went the wrong way with my chamfer. Hey, that happens. It's not a problem. You know, we can come in and define the chamfers real quickly. I think I probably should have cut some more material out of there. So should have gone up 5 degrees. So we'll type in 50 there. And the same thing for this one. We'll type in 50. And there we go. So hey, it's a little bit confusing whether or not you take material away or remove more material. But there you go. We can simply make a simple change, affect the part, and we're ready to move on. So here is that final engineered piece of cardboard. It works very well with the flat pattern tool. If I come up before I generate the flat pattern, I might want to decide, you know, which is side A and which is side B. If I zoom in on the lower skin, if I select that as side A, then when I generate my flat pattern, it will come and show me all the groove or the grooved side of that piece of cardboard. Now, the customer I was working with last week is really concerned about printing a graphic on one side of the cardboard. So I want to include that process in this demonstration as well. Back over inside of Inventor, I want to show you the process of adding the proper appearances to the component. Now, when I add appearances, I tend to just go up to the appearance command right here, I just think it's a little bit easier to find the particular appearances you're looking for. I'm using the Autodesk Appearance Library, which is the very large library, thousands of selections of colors and appearance types. I'm going to look for sisal. There's 3 or 4 sisal parts in here. I'm going to use sisal lines. I think that represents a good representation of that. That's the side of the cardboard. I'll right click and add that to the selection, and I'm going to color the entire part with that color. Now I want to create my own custom appearance. To do that, I'm simply going to duplicate the default color. I'm going to call it multicolored lines. If you want to modify the color, you simply double click it. You'll see the appearance editor. This allows you to select an image. I'm just using a JPEG I downloaded off of Google earlier. The basic one works fairly well in this example, so I'm going to click OK. So here's the new color. And if I select a face, I can add that color to that face. Just simply click it, right click, assign to selection. And you can also select multiple faces with this command. So I can come in holding the control button down, and I can select multiple faces. That small little face right there, this small little face over here and here. We'll simply add those colors, assign to selection. Now sometimes the colors will come in 90 degrees or 180 degrees off from what you want. That's very easy to fix with the adjust command. You can start the adjust command right here. Basically this allows you to select a color, and then if you want to spin it around or reorient it, you simply drag the little rotation tool. So there we have a consistent print on one side of our part. Let's go ahead and flatten that out just to show you the flat pattern tool. If I go to the flat pattern, you'll see the part over here, and if I look at the back, you'll notice that the back is pretty much the wrong way. There is no true association with appearances across the sheet metal flat pattern, but it's very easy to fix. You can simply click the adjust tool, come in right here, and drag it the 90 degrees to the desired orientation. And it will remember that from this point on. So if you go back and forth between the folded model and the flat pattern, it will remember those particular sides. Now I also want to color the inside of the component. They use just a default white color there, so I'm just going to go back in and grab, search for white. There's a number of parts that are basically white here. I'm going to come down and grab I guess my default white. I'll just add this to the document of materials. Then I can come in and select the faces that I want to color. So I've just got the control button selected, picking multiple faces here. Click the white, assign to selection. So now the inside of the part is that white color, the outside is the multicolored line pattern that we wanted to use. And we're basically finished with the design. Again, if I go to the flat pattern, you'll see that that's updated correctly. And if I go back to the folded model, here we go. Now, also in this particular design, if I go back to the chair, you're going to see that the seat has notches in way of the upright supports. So we need to add the notches here. We need these parts to fit together, being already notched out in way of one another. So I simply want to add a couple of simple notches to this part, and that's basically straightforward. Just typical inventor modeling at this point. If I were to sketch on a face here, I can come down and basically look or clip right through the part. As I'm adding the notches, I want to remember that little bit of gap that we had. So I want to make sure I start my lines in way of that outside edge. And sometimes if you wanted to go over that edge a little bit or project the geometry there and then trim to it, That way you know you're going all the way to the outside edge. And then I can add some dimensions. Let me scoot this over a little bit. I'm going to dimension from the outside corner to this edge. That's going to be 1 inch. The width of the gap is 0.375, and the depth of it is 0.5. We'll simply do an extrusion. With that profile, we're going to cut through all, and there is the notch in the part. And if you just let me repeat that, select the back face, just like we did before, I can clip right through there. If you want to project the outside geometries, you can do that ahead of time if you want. Just make sure you select the correct line when you're dimensioning. Make sure I start on the correct line as I draw this particular notch. And then we'll go ahead and add the dimensions. Again, from the outside edge, I wanted 1 inch. I have to pull this over before I dimension the rest of it. That's going to be 0.375. And this one, in this case, is 0.75. We'll start the extrude command. Again, cutting through all. Let me edit that, make sure I'm cutting. And there's the notch. Because we centered the part at 0 all the way back when we started it, we can easily come in and use the mirror command, basically to mirror these two notches on the other side of the XY plane. So here is the part notched out, ready to go. If I were to go back over to the sheet metal tool and go to the flat pattern, you're going to see the notches on the flat pattern, and basically everything's ready for us to go ahead and start documenting this component. Now I already have the chair created. I did that before I started this recording. So I'm going to pick up here with the assembly. Basically I used the same process to create the back of the chair, and I also created just 2 flat pieces of cardboard that make up the sides of the chair. I made sure that the notches match correctly so they engage the desired amount on the sides, and I also made sure that the notches engage at the back of the chair in way of the 2 sheets of cardboard here. So I've got that set up, and I want to begin the process of generating the drawing for this particular design. Now to do that, I'm simply going to go to File, New, and start a standard DWG. I'll go ahead and use my base component. I like the front view of the chair here. I think that looks pretty good. I want to make sure I shade that. I might scale it down just a little bit. Otherwise, it's going to take up most of the sheet here. We'll do the top view, the side view, the isometric view. Right click and select OK. So we've got the views there of the overall chair. Now I want to document the seat portion. So I'm going to go back to my base view. I'm going to browse out to the seat. We'll bring it in by itself, and I think we ought to drop in the basic 4 views like we're used to seeing. We'll go ahead and drop those in position. But when you drop in the seat, we'll go back in and select it one more time. When you drop in the seat, you do have the option to document the flat pattern. Very nice. I can drop in the flat pattern there. I can also document the side of the part, which in this case I think is pretty important to do. We can pull up this, maybe make it a little bit bigger. Right click and select OK. Let's pull that out a little bit so you can see that a little nicer. So I can document the flat pattern. I can document the side view, and then we can begin the process of adding the annotations. So this is going to conclude this demonstration on working with grooved cardboard or foam board utilizing the Inventor Sheetmetal commands. If you have any questions about the contents of this video, please feel free to reach out to your Imaginet Technologies account manager or support representative.